This is Hydro Falls in Guyana, which is located in South America but culturally linked to the Caribbean. In this paper, we present our evaluation of an adaptable, hybrid STEM robotics curriculum we developed for the Special Educational Needs or SEN community in Guyana. Training and academic support was managed by the University of Guyana Computer Science Department and their Robotics Club, UGRC. This research is financed by the Guyana Council of Organization for Persons with Disability, GCOPD, who in turn are financed by ExxonMobil and the former Ministry of Public Telecommunications.
About 1 in every 6 people worldwide live with some form of disability according to the WHO. Alarmingly, students with disabilities are likelier to drop out of school before completing their primary or secondary education, and as a consequence, their full integration into society may be hindered. In Guyana, this problem is prevalent as well, with a reported 11,000 living with a disability. To address this problem, the UN has taken a rights-based approach towards developing and implementing inclusive policies and programs to ensure equal opportunities for persons with disabilities. Similarly, the GCOPD has been operating at a national level to develop programs that expose youth with disabilities to 21st century skills.
The World Economic Forum predicts that in the near future, the vast majority of workplaces will require digital skills. In 2020, the first STEM robotics program for students with special needs was launched. This program had to be adapted to hybrid mode after the global COVID lockdown. The objective was to provide an avenue for the development of digital skills in students with limited access or exposure to STEM education and digital literacy.
In this program, 48 students were enrolled with a range of disabilities among 5 local SEN schools. Their age range was substantial, with the youngest at 11 and the oldest at 27. Some basic digital literacy was expected of the students outright, such as being able to use a smartphone or tablet. In our analysis, we simplified and grouped the various disabilities by type. Out of the 5 groups, 3 had a mix of various disabilities and 2 had a single type of disability. 7 mentors oversaw the sessions, with 2 to 4 assigned per session per group, in charge of planning, conducting, and documenting the 12 weekly sessions. Before each session, mentors met to assess and tailor contents to a particular group. Then, after conducting a session, they logged their feedback using a survey tool. Each week, mentors met and discussed their feedback issues and brainstormed ideas in order to better deliver subsequent sessions.
This is what a typical project session looked like. Here you can see students are following along the instructions of a simple robot build, accompanied by the mentor using visual guides by the Zoom tools. This was another hybrid session. Here the student is following along the presentation on their phone, but receive additional assistance from teachers on site, as well as the mentor remote guidance over Zoom.
There were 2 content delivery modes, with mentors online. The fully online mode had students at home and received support from their guardians. Alternatively, in a hybrid classroom mode, in this setting teachers would assist students in person. As mentioned, there were at least 12 weekly sessions for each group, and each focused on introducing core STEM concepts using methods enabling students to develop their skills. There were several tasks they had to complete in order to graduate, including preparing and presenting various projects and homework activities. Credits were assigned to various tasks, helping us keep track of student performance and at the end of the program establish whether they would qualify to graduate.
We delivered the 2-hour sessions over Zoom. Using Google Classroom, we shared information and oversaw homework progress. And WhatsApp was perfect for informal and direct communication.
With this paper, we wanted to evaluate the experiences of the mentors who delivered this curriculum. To that end, we gathered assorted mentor feedback and other stats throughout the program's timeline. We then conducted a basic analysis using Python pandas, analyzing available session stats and other quantitative data. Meanwhile, Rosette's text analytics platform helped us evaluate key qualitative sentiments from mentors' session feedback.
Overall, mentors observe an improvement in students' skills, namely critical thinking, environmental awareness, and presentation skills. About 90% of students graduated, with the rest reporting scheduling conflicts or a general loss of interest. The conducted program now represents a new and accessible STEM curriculum in Greater Guyana. Mentors benefited with hands-on teaching practice in challenging settings. Finally, parental and teacher support was documented, aiding students' learning journeys.
Mentors overall noted several environmental constraints throughout the sessions. The first few training sessions at the start were usually spent troubleshooting setups and resolving basic setup issues, and this was very time-consuming. Additionally, mentors reported frequent issues related to network and power line services quality. In fact, this was a consistent issue throughout the program, thus each group had several redundant mentors assigned in case one experienced an outage. Students attending from school overall experienced the least reliable internet connectivity. Oftentimes, school staff had to host entire sessions using their smartphone data plans. According to Chandra et al., these exact issues are crucial to address in order to facilitate more robust learning experiences.
Project presentations were an exciting event for both mentors and students. We felt encouraged finding that students progress regardless of disability or other factors. Most students completed the activities, but towards the end of the program, mentors noted more frequent accounts of absentees. This was associated to frequent power and network outages, in addition to other conflicting school activities. Regardless, absent students were contacted and encouraged to make their outstanding presentations, and many presented their projects using video or voice recordings. While initially struggling to derive ideas, most students presented their capstone projects, often reusing components from previous projects. Mentors noted working out of class to help derive student ideas into tangible outputs, and we thought this was very positive. However, in the future, additional guidelines could be made available to students, making the overall progress less demanding on staff.
About 2/3 of students were observed as active throughout all sessions, specifically groups C and D. This means the students would consistently partake in sessions inquisitively and with an eagerness not prompted by mentors. For Group C with visually impaired students, mentors made the materials more accessible for screen readers and featured fully descriptive explanations. Group B was initially the most challenging to work with online for the mentors, as they lacked prior sign language experience and had to rely on teachers for interpreting materials for the students. Poor network infrastructure at the school made things even more difficult. So for this group, the mentors adapted by working with the teachers beforehand to review and simplify the materials, as well as include sign language animations in the content. The hardest groups to work with were groups A and E, due to a high proportion of intellectually impaired students, in addition to wider age ranges. Mentors adjusted their strategies here as they got to know the students and better cater to their engagement. Thus, the sessions for these groups ran at a slower pace, focusing on simpler sentence construction, ample visual materials, and hands-on activities.
For students joining from home, their guardian took part as well, providing a great source of encouragement and assisting students with their assignments. This led to a positive impact on student success. We validated this observation with Beers and Wilder's observation that parents' participation refers to their interest in their child's academic success.
Teacher support for students was also observed, helping provide access to materials and maintaining student engagement. But teachers also provided support to mentors, providing invaluable advice and feedback, as well as improving delivery methods. According to McClure et al., teachers exhibiting enthusiasm and promoting engagement in STEM curricula pass on their excitement.
In conclusion, we presented mentors' experiences and observations, along with other stats as key findings on lessons learned from the inaugural STEM robotics program for special educational needs students in Guyana, delivered hybridly in 2020.
Kind support from teaching staff and guardians helped ensure a high graduation rate and overall positive improvements in students' hard and soft skills. These observations helped validate fundamental threats to hybrid and fully online special educational needs programs in the region and these findings are used to extend the curriculum to feature a more permanent addition to SEN education in Guyana. Lessons learned from our analysis may prove crucial for this and future related programs.
These were our findings from the Hybrid STEM Robotics program for students with special needs in Guyana. Thank you for your attention. We look forward to addressing your questions.